Alright, this is section 5.6 about parallel and perpendicular lines. So you have two goals. First one is I can determine if two lines are parallel, perpendicular, or neither. The second one is I can write equations of parallel and perpendicular lines. And we're going to actually do those in the order that would be backwards. We're going to flip those around. But two goals for today dealing with parallel and perpendicular lines and their equations. So let's start with a couple of vocab words. What are parallel and perpendicular lines? Now these are words that chances are you've seen before. You know what they are. At least have an idea. But just as a reminder, parallel lines mean that they're lines that are never intersecting. They'll never intersect. They're on one plane, like a two-dimensional figure shape, and they'll never intersect. All right? They'll just go on forever without ever crossing. Now perpendicular lines are kind of the opposite. They do cross, they do intersect, and they form right angles. So if two lines intersect, so like for right here we'd have two lines, like the lines on this paper here. These are parallel. They will never intersect. But for right here, if we had this line right here and the line that I drew originally, these are perpendicular because they form right angles, 90-degree angles. And we're going to talk about how we can relate the two different things with equations. So first thing to talk about. Slopes of parallel lines. So if we read the essential understanding up on top here, it says you can determine the relationship between two lines by comparing their slopes and their y-intercepts. So if we look at the slopes of parallel lines, if we say in words here, it says non-vertical lines are parallel if they have the same slope and different y-intercepts. So that makes sense. If they have the same slope, they're going to be going up or down by the same rate, and they'll never actually cross. Um, the second part there, if they're vertical, they just have to have different x-intercepts. But, so an example here, if you look at the example, the graphs of y equals 1 half x plus 1 and y equals 1 half x minus 2 have the same slope. They both have the same slope. That's what's in common here. That means since they have the same slope and they have different y-intercepts, so they cross at different places, you look at the graphs over to the right, they are parallel. Okay, as long as they have the same slope. Up 1 and over 2, that's 1 half. Up 1 and over 2, that's 1 half. Same slopes, just different starting points. So let's write some equations of parallel lines. So to write equations of parallel lines, um, it says a line passing through 12,5, the point 12,5, is parallel to the graph of that equation, y equals 2/3 x minus 1. What equation would represent that? So what we're going to do is determine the slope. Once you determine the slope, you just use that slope because it's got to be parallel, meaning it's got to be the same slope. So if we determine the slope, use that slope and the point to write the equation. And we can do that either using point slope form or using slope intercept form. It really doesn't matter. We've learned two different ways. So here's our steps. Let's do this. Looking at y equals 2/3 x minus 1, the slope is always the number in front of the x. That's where that m would be. So the m has to be 2/3. And we want it to go through the point 12,5. So I'm going to use the slope-intercept method. That's what I like better. Maybe you prefer intercept using point slope form, plugging in the point and the slope, and then solving it for y. But we want to write it in slope-intercept form, so I'm going to use the slope-intercept method. So we've got y equals mx plus b, right? Where the b is the y-intercept, that's what we're actually trying to find. The m is the slope, we have that, and the x and y are an x and y coordinate, which we have. We have the m, we have an x, and we have a y. So let's plug those all in. So for that y, we're going to plug in 5. For the m, we're going to plug in 2/3. For that x, we're going to plug in 12. And I'm going to write that as 12 over 1 right away because we're multiplying fractions. And then we have plus b. And we want to solve for b. So we can figure out the b. We have the m, we got to figure out the b. Alright, so to solve for that, let's see here. I'm going to cover this up here. I'll actually slide that down a little bit farther so we have more room. Alright, Continuing on, this is going to be 5 is equal to, let's multiply this across. We have 24, actually we'll go like this. This is going to be 24 over 3, which is equal to 8, or 8 over 1. So I'm going to plug in 8 right here, because that is 8. We simplify that, that's 8, and plus b. And to solve for b, we're going to do our one step, subtract 8. So negative 3 equals b. So b is negative 3. Now we have the two things we need, the b and the m. Put it all together. Y equals 2/3 x plus 8. So that line we know is parallel to the one we were starting with because it has the same slope and it goes to a different y-intercept, which is what we had to figure out using the point that we were given. Alright, so take note on that, and I'm going to have you try one on your own. It says the line passes through the point negative 3 and negative 1 and is parallel to the graph y equals 2x plus 3. What equation represents the line in slope-intercept form? So go back to those steps and try this one. Alright, so feel free to skim my work here. I found that the slope had to be 2 because that's what we were given in the equation. I found that the y-intercept, we could figure that out by plugging in the x and y that we were given, solving for the b, and then using that along with the m that we had to make our equation. Y equals 2x plus 5. So that's parallel lines. Now we're going to look at the second thing, which is perpendicular lines. So slopes of perpendicular lines. In words, it says the slopes of perpendicular lines are opposite reciprocals. Perpendicular lines, the slopes are opposite reciprocals. So we do not have the same slope. But it's very specific. They have to be the opposite and the reciprocal. So we look at our graph, we have y equals 1/2 x minus 1, and we have, so that would be the slope of 1/2. Y equals negative 2x plus 1. So it's a slope of negative 2. Alright? Now if you multiply those two slopes together, you end up with negative 1. So that's a unique similarity between slopes of perpendicular lines. But they're also opposite signs. So one is a positive, one is a negative. And they're reciprocals, meaning if you don't remember what reciprocals are, the fraction is flipped. So this would be 1 over 2. The negative 2 would be negative 2 over 1. All right, so that's why they're perpendicular lines. So additional examples, if you had 2, the opposite reciprocals would be negative 1/2. Okay, if you had negative 1/3. Opposite reciprocal, opposite would be a positive, and the reciprocal would be 3 over 1, or 3. All right, let's say you have 2/5. The opposite reciprocal would be negative 5 over 2. So again, those are all examples of perpendicular slopes. One is a positive, one is a negative, and they're reciprocals. So let's work with an example here. We have, which equation represents the line that passes through the point and is perpendicular to that equation? So I have 4 options, and we're going to figure out which one. So here's the steps that we're going to take. We're going to just really add one step. So we're going to find the slope of the given line, or a given equation. All right. What we're going to do with that then is write the opposite reciprocal slope. That's one we're going to use. Then we're going to use that slope and the point to write the equation. All right. So let's follow those steps. Let's find the slope of the given equation. So the given equation is y equals 1/3 x minus 1. So our slope then is 1/3. So the slope has to be opposite reciprocal of that. So step 1, 1/3. Step 2, find the opposite reciprocal. So m is going to be a negative 3 over 1, or just 3. Okay, there's our m. Now we have to find our b. So I'm going to use the same slope-intercept method like we did before. Let's use the point. So we have 2, 4, and we have the m. So we're going to do, and for y equals mx plus b, remember, m goes right there, x goes right there, and the y would be the 4. It goes right there. So we have 4 equals negative 3 times 2 plus b, and we got to solve for b so we can write our equation correctly here. I'm going to slide this down so we have some more room again. Now to solve that, let's do that multiplication first. We have some multiplication we can do. That would be negative 6 here. Get that out of the way right away. And then we just add 6 to both sides. And we end up getting b is equal to 10, which is great. We have our b and we have our m. So let's rewrite the equation as y equals negative 3x plus 10. All right, so take note on that. That's the second skill we're doing, is writing perpendicular lines. And here's an example I'd like you to try on your own. A line passes through 1,8 and is perpendicular to the graph y equals 2x plus 1. Right? What equation represents the line in slope-intercept form? So it's got to be perpendicular, and we have the information there. So do that one on your own. It's really important that you do this one so you get the practice and you can see the feedback of what you did. Alrighty, so we followed the same steps. I found the slope from the original equation, which is 2, right in front of the x there. That's 2. Found the opposite reciprocal slope that we're going to use. So its opposite would be a negative, and the reciprocal instead of 2 over 1 would be 1 over 2. So our slope that we're going to use is 1/2, negative 1/2. I plugged that slope in and the point, so we have x and y, in for the equation here to solve for b. And I got 8.5 for b. I got my b and my m, I put it back into the slope-intercept form, and there's the equation of the line that would be perpendicular to the given line. It also goes to that point. All right. So last thing we're going to do is we're going to look at a couple examples and just decide if it's parallel, if they're parallel, perpendicular, or neither. So what we have to find is, well, we're going to do that. So first of all, make sure each equation is in slope, intercept, or point slope form. Why are we doing that? Well, we got to figure out what the slope is, and both of those equations, those forms, tell us the slope. So hopefully they'll be written in one of those two things. All right, then we're going to find the two slopes. And then we're going to determine if they are parallel, which would be same slopes, or perpendicular, opposite reciprocal slopes. Or neither. Maybe they're not going to have either of those. All right. So let's look at this example. Are the graphs 4y equals negative 5x plus 12 and y equals 4/5 x minus 8 parallel, perpendicular, or neither? All right. Well, I can see from the second one this is already in slope-intercept form. So the the slope is 4/5. But the one on the left, we don't have it in either form. So I'm going to quick solve it so we have it in slope-intercept form. So by doing that, I divide both sides by 4. And we have y equals, we'll divide the negative, so it'll be negative 5 over 4x plus, and then 12 over 4 would be 3. So now we have the slope, because it's in slope-intercept form. The m is negative 5 over 4. So they're definitely not the same slopes, but they are opposite signs, and they're reciprocals, so they are perpendicular. Because they're opposite and reciprocal. All right. So try this one on your own. Actually, I have two of them. Just try to figure out those two. Rewrite those so you can find the slopes and determine if they're parallel, perpendicular, or neither. So finishing up here, letter A. Once I solved the second one for y, I got it in the slope-intercept form. I found that the slope of the first one was 3/4 and the slope of the second was 4/3. And this is tricky. Take note of right here, when you divide this, negative over negative becomes a positive. It doesn't, just because there's two negatives doesn't mean it's going to be negative. When you divide, it's a positive. So that's why we have opposite, or sorry, we have reciprocals slopes, but they're not opposites, so we don't know. They're not parallel or perpendicular. So I put neither. Letter B, though, when you solve the first one for y, and you get the slope-intercept equation, found the slope was negative 1/6, and the slope from the second one is negative 1/6, meaning they're parallel, because they have the same slopes. So just to recap what we talked about today, parallel lines are lines that never intersect, and they have the same slopes. We talked about that. Perpendicular lines are lines that intersect to form right angles, and if we know that they're perpendicular, they have to have opposite reciprocal slopes. And we worked with those to write equations and to determine if they're parallel or perpendicular. So there's the goals, recap those, and I hope you learned something about parallel and perpendicular lines today.